to say welcome, everybody. Thank you for joining us for the final presentation of the 2021 Lectures in Mathematics Education series. We have learned about critical topics in mathematics education from a number of distinguished speakers, and today we are happy to hear from Amanda Jansen and Jen Kelly, both joining us from Delaware. The Lectures in Mathematics Education series is sponsored by the Herman and Roche Math Initiative and the University of Southern California's Rossier School of Education, with the goal of highlighting important research targeted at improving teacher effectiveness in mathematics education. We are thankful to have been able to provide access to this series virtually and for our guest speakers and everyone joining us in the digital space. Today, I'm happy to introduce Dr. Jansen and Jen Kelly, who will be giving a talk entitled Mathematics Teaching Practices That Can Support Secondary Students' Engagement. Dr. Amanda Jansen is a professor in the School of Education at the University of Delaware. She's a mathematics educator who conducts research on students' engagement in mathematics classrooms and teachers learning from their reflections on their own practice. She is committed to honoring students' and teachers' voices through her research on students' motivation and engagement. Her most recent book, Rough Draft Math, Revising to Learn, was published by Stenhouse Publishers in March of 2020. Hold on a second. Before working in academia, Dr. Jansen was a junior high mathematics teacher. At UD, she is invested in continually improving UD's elementary mathematics teacher education courses through research and development work. Presenting with Dr. Jansen is Mrs. Jennifer Kelly, who is a mathematics teacher at St. George Technical High School in Middletown, Delaware, in the Newcastle County Vocational Technical School District. She has taught at the school for 7 years and also taught middle school mathematics for 3 years prior to her current teaching position. After the presentation, we will have time for questions, and at that time, we would like you to pose questions in the chat box, and we will get to as many as we can. Thank you again for joining us, and at this point, I'm pleased to turn it over to Dr. Amanda Jansen.
Thank you, and I really appreciate the opportunity to share this evening, and thank you to the initiative for funding these talks. When I was invited to give a talk, I was very excited when I was prompted to say, please include a teacher collaborator in the presentation. And so I was really excited to invite Jen to present with me tonight. And we had a great time preparing for this talk, and we're happy to share it with you. So Peter introduced us a bit. And this is a cover of a book that recently came out, but no, I'm not talking about that book tonight. I would like to just also give Jen a chance to introduce herself. So let's go back to this slide. So I'm Mandy, and then Jen, why don't you say hi?
Hi, everyone.
Say a bit about yourself.
Sure. Right now, I'm a high school mathematics teacher at St. George's Technical High School in Delaware. And I love teaching at St. George's. It's the best. I have a bachelor's in mathematics and a master's in secondary mathematics. Again, I have 10 years of teaching experience, 3 years at the middle school level, and the past 7 years at the high school level. Very happy to be here. Mandy, thank you so much for including me.
Thanks. And I would like to acknowledge that the data we're going to share today is from a larger study funded by the National Science Foundation. The study is called the SMILES Project, Secondary Mathematics in the Moment Longitudinal Engagement Study. The principal investigator of the study is Jim Middleton at Arizona State, and I'm the co-PI. And you have the names here of our awesome collaborators, the doctoral students and undergraduate researchers that have worked with us. And of course, we couldn't learn anything if the teachers and the students hadn't shared their classroom experiences with us. So there are a lot of folks to whom that we can thank for the opportunity to share with you today. So the problem that we're trying to solve in the SMILES project is the notion that as students move through their education, their motivation and engagement decreases. It's true in math, and it's true in general, and lots of studies show this. And we want to disrupt that. So lots of studies will find findings like this, but here is one. Typically, students' self-efficacy, enjoyment, sense of utility of math decreases as they move through middle school and into high school. The longer students are in school, the more disengaged they tend to become. So teaching can disrupt this pattern. And so we want to understand what teachers can do. So thinking about how you can support students' engagement, it's important to understand what engagement is. So one of the challenges with creating motivating and engaging environments is that engagement can mean so many different things. And how you think about engagement affects what you would do to engage students. So one way to think about engagement is as investment. Investment in something pedagogically relevant, like a math problem, and it's situated in a relationship. There's the student, the thing that they're engaging with, and then the interactions they have with other people in their environment, like peers and the teacher. But engagement can have many different dimensions. I can be cognitively engaged, such as how much attention I'm paying, the kinds of connections I'm making, basically how I'm thinking while I'm invested. Behavioral engagement can be the amount of time on task you're putting in. But you could also be thinking about affective engagement, your level of interest, your level of curiosity. Or you might think of engagement in terms of social interactions, mathematical discourse, talking with peers about mathematics. So how you think about engagement is likely to then shape what you would do to try to engage students. And why engagement is important is because it's part of the process of learning. There are lots of studies that show that higher engagement leads to stronger performance. Like here's one: higher levels of cognitive, behavioral, emotional, and social engagement predicted secondary students' course grades in math. So the notion that if engagement leads to learning, we need to understand how to create more engaging learning environments. However, it's understood that secondary students' engagement with math can be supported through instruction because engagement is constructed. It's an interaction with learners and their context, the people in the context, the kinds of problems they're able to do, how the teacher creates that environment makes a difference. I was the co-author of a chapter about mathematics engagement for the Compendium for Research in Math Education with my collaborator, Jim Middleton, and Jerry Golden at Rutgers University. And this compendium it's a handbook, and they represent the state of the field in terms of a literature review of what does the field currently know about, in this case, math engagement. And so I have a quote from this literature review: the importance of a malleable factors that a teacher, curriculum designer, or educational leader can influence to encourage deeper, more productive engagement. And it's really these in the moment adaptations of learning conditions that make a difference for engagement. So through conducting this literature review for the compendium chapter, we came up with a series of conjectures of how teaching can impact students' engagement. It's our best working hypotheses of ways that teaching can support students' engagement. And so we came up with a series of hypotheses related to academic support. And then the next slide I'll show you will be social support. So academic support for students' engagement would be, for mathematics classrooms, opportunities that teachers provide for students to engage in sense making and reasoning, opportunities to make conceptual connections. You can imagine connections there to cognitive engagement, the kind of thinking that students would be able to do. Could be also affective engagement, how they feel about what mathematics can be, and if they're interested in something that's more conceptual when they can make sense of it. Pressing students to explain their thinking, there's direct implications there for social engagement. And it could also be affective engagement, where they feel like valuable thinkers. Providing students with specific and detailed feedback help students persist and keep going, perhaps, or maybe cognitive engagement. Opportunities to solve math tasks in context. We could imagine that could be affectively engaging if they think math is more interesting when it's in context. Could be cognitively engaging. Students could reason and make sense of the quantities in the context and so forth. But these are some of our conjectures of ways that teaching could support engagement that we wanted to investigate. We also looked at our conjectures of how teachers could support students socially that might impact their engagement in secondary classrooms, such as giving students opportunities to engage in collaborative discourse at the whole class, small group level. Motivational discourse, previous research in educational psychology, such as the work of Julie Turner, highlights this role of motivational discourse when a teacher puts the focus on learning and sense making, over performance or correctness. Creating an atmosphere with more positive affect, maybe humor, encouraging students to collaborate and work together. They came up with this category of motivational discourse that had an effect on middle school students' motivation, and we wanted to see if that had an impact on high school students. Positioning students as competent is something we'll get into quite a lot in this presentation. Comes out of the complex instruction, and I'll explain that more, but highlighting specific strengths in students thinking about mathematics could support students' engagement. And connecting to students' lives outside of the classroom could help students feel more connected to mathematics, more connected to the classroom experience. Again, these are some conjectures that we wanted to explore in this work. So the research question that we'll be elaborating on today, I'll share it more than once, but I'll share it now. What ways of providing academic and social support during instruction? So I gave you some conjectures about what academic and social support could look like. Align with students' reports of productive engagement in the moment in secondary mathematics classrooms. So this is a study of observations of teaching and immediately asking students about the experience they had. So here's the headline result that Jen and I are going to unpack for you today and help you see what this looks like. High school students reported higher degrees of participation in math learning activities or social engagement during lessons when teachers made efforts to position students as competent, this status raising idea that we'll really be explaining a lot about tonight, and then when teachers use motivational discourse. So this is the headline, and now we're going to unpack and show what that looks like and how we came up with this result. So as I mentioned, it's an observational study. For this project, we developed an observation protocol to examine our conjectures about effective teaching or teaching that could support students' engagement. And immediately during that observation, students gave their self-reports of motivation engagement from a modified version of the experience sampling method survey that has been used previously to investigate maybe the concept of flow that I'll talk about in a bit. So when we observed teaching, we solicited teachers to participate in the study if they were interested in thinking about engagement with us, nominations from math coaches in certain senses. And then we asked the teachers, when can we come visit? They could pick a day when they thought that they had a potentially engaging activity. Teachers selected an activity during the lesson. So lessons might be 50 minutes or they might be 90 minutes, but teachers decided there's one part of the lesson that I think is going to be more engaging than others. Let's focus on that. So we analyzed the activity that the teacher selected would be potentially the most engaging for students. It's a way that we're bringing teacher voice into the study and letting teachers nominate what could be engaging for students. And then immediately after that activity could have been at the beginning of the lesson, middle, not necessarily at the end, the teacher would stop the class and then the students would take a survey about their experience in that activity. And I'll share more about that survey later. But first, I'll talk to you about how we observed math instruction, the observation rubric that we used, and you'll see more about what the teaching practices look like, and that's going to be a case from Jen's classroom. This slide has a lot of information on it. On the left, I'll talk about how we developed our observation tool, and on the right, I'll talk about how we used it. So we developed the observation tool using some relatively standard practices. For doing so, we first started for conceptual validity reviewing literature. I mentioned the handbook chapter, the compendium chapter, and other reviews of the literature. And we reviewed also pre-existing observation tools from mathematics classrooms to see if any of them were getting close to some of the conjectures that we found in the literature about how teaching could support students' engagement. Most of the pre-existing observation tools were not so connected specifically to engagement, more connected to learning. So we had to create a number of rubrics. And so then we piloted those rubrics using publicly available lessons from the TIM study, the Third International Mathematics and Science Study. And then we modified them and added some other rubrics to capture things that were happening. Then we vetted the rubrics and the levels in the rubrics with experts. Our advisory board and others, and they gave us feedback about different maybe rubrics we should consider for other domains. We've conducted a reliability study. When we use the rubric, we always have two coders looking at the episodes. And so we studied when there were disagreements with coding, if coders disagreed because they noticed different evidence, or if they disagreed because they were interpreting the rubric levels differently. So the shorter answer to that is usually they were noticing different evidence, not because the rubrics weren't clear, but because there's so much going on that different coders would have attention for things. So it ended up being more inclusive to have two coders. So we used the observation tool by, as I mentioned, applying it to a teacher-selected activity. And that's that teacher-selected, potentially engaging activity. We call that an episode. But each episode could be of varying length. They were on average around 25 minutes, often cases. And so we divided the episode into 10-minute segments, and then the last segment's a little bit less than 10 minutes. And two coders assigned ratings to this 10-minute segments. Then they met to resolve disagreements. We have 15 different rubrics. So every 10 minutes, their lesson is getting a score for 15 rubrics, meeting to resolve those disagreements. And then there's an episode score that ends up being an average of the segment scores for each of the 15 rubrics. These are all of the rubrics. They aligned with the rubric titles, aligned with some of the conjectures I mentioned earlier. And I'm going to key in specifically to the status raising rubric. I'm going to show you an example of the rubric levels. We have levels from 0 to 3, so 4 levels for all of the rubrics. And the status raising rubric was an important finding, so it makes sense to unpack that further tonight. So the phenomenon of status raising comes out of the work of complex instruction. Cohen and Lotan have studied this in lots of subject areas, not just mathematics. So status raising keys into the notion that there are hierarchies of status in classrooms related to students' academic level of competence. It's basically the notion that in a classroom, you might think of some people as they're the math person or they're the smart one, but all students actually have mathematical smartnesses. And so teachers can see the smartness in different students in the room, name their mathematical strength, and say how that strength helps the class learn. And so then the teacher is assigning competence to students, and more students can be seen for that mathematical smartness that they have. So teachers can learn to do this. This has been shown in research literature, naming and describing a specific student's thinking, explaining how that person's thinking is helpful for the group's learning, identifying the strengths that students have mathematically, and then more students can be seen for their mathematical smartness. And this can disrupt hierarchies of competence in that classroom, potentially raising the status of that student in that room. And again, all students have mathematical smartnesses. So when a teacher does this, it can have benefits for how students see themselves and how they're seen by others. So this is our rubric that we designed for this phenomenon. It's when a teacher publicly names students' mathematical and intellectual strengths and indicates how that strength forwards the understanding of the class. That's how it helped us all learn. And what's important is that this is public. The teacher shares this with the whole class. So the highest level of the rubric is when this happens frequently. And students can start to do this for other students too. So either the teacher or the students are often using language that magnifies students' strengths. The next level is this happens once in a while. Sometimes the teacher or the students are identifying strengths in the class members. And this can be for a small group too, like, oh, this group was thinking about, but it's usually a specific student. Minimally present is more neutral language about folks' mathematical thinking. And then the lower level is you are going to hear some deficit language. They're not really talking about somebody's thinking in positive light. It's actually, you're going to hear some negative sometimes. So the data that we use to analyze for this talk comes from the 2018-2019 school year. we have the study set in, well, it says Mid-Atlantic and Southwest, but you've already seen the states the PIs are from, so you know which states this is. But we have 3 schools in 2 different states. And this gives you a sense of the demographics, the range of the demographics across the schools that we worked with in each state. So you can see there's different kinds of diversity in the different states that we were in. So I'll give you a moment to check that out. And we were working that year with 9th grade, primarily on grade level 9th grade classes. So there would be a mix of not all 9th grade students in the room, but that's the type of math class we were working in. And so in the Mid-Atlantic region, the classes lasted a semester at a time. So they had 90-minute class periods, and a semester is equivalent to a year of mathematics. So they had integrated math 1 in the fall and integrated math 2 in the spring, 90-minute block courses for a semester. And in the Southwest, it was year-long, equivalent to Algebra 1. And so they were shorter, about 50 minutes or so. And in both cases, the teachers selected activities that we focused on. This year of the study, we had 16 teachers, average of almost 11 years of teaching experience, but you could see there's a wide range of years of experience in the study. And teachers were recruited. First, we had relationships with the districts and then the schools, and math coaches helped us identify teachers who'd be willing to participate, and then snowball sampling from there. Once teachers were involved, they also got their colleagues involved. And you can see that we asked the teachers who are participating to identify their race and gender. And so mostly white, and 1 Asian American teacher this year of the study, and 1 Hispanic Latinx teacher. And 11 of the teachers identified as female, 5 as male. So to see what the phenomenon of status raising looks like, because this is one of the teaching practices that correlated with high levels of social engagement with their students, Jen was generous to join me in this talk today and share a bit about what this looked like in her classroom. So I'll turn it to Jen.
Thanks, Mandy. So this is the demographic breakdown of St. George's during the fall of 2018 to the spring of 2019. And the class that we're going to take a look at today is a subset of that demographic data that's presented here. Next slide, please. So this lesson is the first lesson of our exponentials unit. And I started the lesson by reading aloud the book 1 Grain of Rice to the students, which is about a young girl named Ronnie who outsmarts a very greedy king into giving her more rice than he expects. And students at this point have a general understanding of how to use exponents, but they don't have any experience writing equations for exponential functions. I thought that this would be an engaging cognitively lesson for students because there's a major shift when working with exponential functions compared to the student's first unit, which was linear functions. And with linear, we're dealing with repeated addition, repeated subtraction, but with exponents, students would have to shift their thinking to thinking about repeated multiplication. And this book, 1 Grain of Rice, depicts a real world application of repeated multiplication. Next slide, please.
And just before you go on, I just want to clarify this information here. Before we visited each teacher's classroom, they filled out a Google form for us about information about the goal of the lesson and which activity we should be focused on. And I was always so curious about their conjectures about why the activity would be engaging. So I appreciate that Jen reflected on that here with us.
Sure. So after I read the story, students calculated how many grains of rice Ronnie had on day 30, and they were very surprised that she had over 1 billion grains of rice. The goal of the lesson at this point really is for students to figure out and think about a variety of different equivalent mathematical strategies that they could use to figure out that if they knew how many grains of rice Ronnie had on day 30, how could they figure out how many grains of rice she had on day 35? And we weren't really interested in figuring out how many grains of rice she had on day 35. We were more interested in figuring out how could you calculate that, knowing how many grains of rice she had on day 30 and understanding that repeated multiplication by 2 was occurring each day. Next slide. Thank you. So this was up on the board while we were gathering students' strategies. You can see that one of their strategies is to multiply by 2 to the 5th power. And as time went on, we gathered a couple of other equivalent mathematical strategies that students gained through small group conversation. Next slide, please. So this right here is a transcript of some of the conversations that took place during the lesson. And this slide specifically looks at students who are debating whether or not the grains on day 35 would be represented by 2 to the 34th power or 2 to the 35th power. So Mandy and I are just going to read the transcript together. The only reason that she's not right is because you guys aren't taking into consideration that day 1 was day 0, 1 grain of rice.
Oh, so I was right?
You're on the right track. It's not actually to the 35th power, it's to the 34th power because we didn't multiply by 2 on the first day.
I mean, I'm still right.
Your thought process is very, very good. So we're just going to leave it like this. Jaden, you were the only one who caught it, that we didn't multiply by 2 that first day.
I caught it.
Also, I'll wait for you guys. What's another way to show this? How would you show times 2 to the 5th power? Marcus?
Times 5 to the 2 power?
So you say that's the same, 5 to the 2nd power? Well, I'll let you guys figure it out. So there's some examples of status raising language in this transcript. So my comment to Anna represents status raising language because even though her calculation was wrong, her thought process was on the right track. So she used the wrong exponent, but she was using exponents, which was what I was hoping that she would be doing. So in that respect, I did praise her for, not necessarily having the right answer, but for thinking mathematically. And Jaden, of course, got noticed publicly because he was indeed the only student who actually caught that difference between the day and the exponent. So, and he was very, very pleased with himself. Next slide, please. So at this point in the lesson, we are looking for patterns in the relationships that are created to calculate the number of grains of rice Ronnie receives each day, with the ultimate goal of writing the equation that can be used to calculate the number of grains of rice on any day. And students are using their prior knowledge of what they learned in their linear unit with respect to the idea that we know we need a starting value, which in this case was 1 grain of rice. They know they need a rate of change, and the grains of rice were doubling each day. And so this rate of change is very different than what they had seen in the past, right? They were in their linear unit focusing on repeated addition and subtraction, but here now they're noticing that it's a repetition of multiplication. Anything that's written on the board is all represents students' thinking from the class that was solicited by questioning. Next slide, please. So at this point, this transcript is discussing how the exponential relationship between quantities is different from linear functions. And this transcript represents my interaction with a student, Maria, who had a very notable comment that she had made within her small group. And with respect to the rate of change in this situation compared to what we had seen in our previous unit. And it was an incredibly important comment and observation that I felt needed to be shared with the whole class. Maria, you said something that was very interesting to me.
Well, I said that linear functions or constant rate of change will have constant change. Well, this does not, so it doesn't have it.
Exactly. So this is a non-constant rate of change. Non-constant rate of change. Did she receive the same amount of rice every day? No, she received more and more rice every day. So this would be an example of status raising language because I pointed out a student's very powerful observation to the rest of the class because they could all benefit from her thinking.
So we wanted to share that example because Jen's lesson had so many different cases of identifying students' mathematical strengths in very specific ways publicly to the whole class. So that way you could see what this phenomenon looks like. I would now like to share how we measured and studied students' engagement. We used the experience sampling method that I'll describe more because ultimately we wanted students to be the informants. Whether or not instruction would be engaging would be dependent on how the students reported their engagement. So the experience sampling method, we collected these data in 72 lessons. So 16 teachers, but 72 lessons because teachers have multiple class periods. And we analyzed the potentially engaging activity using those observation rubrics that I described earlier that we applied in 10-minute segments to teacher selected potentially engaging activities. And then we received opportunities to study student self-reports of engagement in the moment. We happened to be at schools where it was one-to-one with Chromebooks. We were prepared for our grant to get devices for students to fill out a survey online, but the schools had Chromebooks. So after the lesson, the teacher would say, okay, get out your Chromebooks and go to this link. And so the students completed these experience sampling method surveys right after that activity about their experience. So what are these surveys? The experience sampling method was originally designed to capture flow. Flow is intense effort and concentration, but also coupled with interest. It's that I'm so into it that I lose time. So there were studies of flow even in the late 80s and 90s. And what they would do is they would give people beepers and they would buzz people and they would say, what are you doing right now? And they would ask them a series of questions about their experience of whatever they were doing to try to identify when flow moments were occurring. So we took that concept, what are you doing right now? And we modified that survey and we developed items to capture students' motivation engagement specific to math learning. So these were items that were from a 1 to 5 point scale, about 3 to 4 items per scale. And so these data are, like I said, from 72 lessons and about 765 students. And so Jen's case was a sample case of one of those lessons. So here are some of our scales with sample items and the reliability for the scales, just to give you a flavor of the kinds of things that we asked the students to share with us. So one of the scales was interest. So a sample item might be how much students were enjoying that activity. Cognitive engagement of how much intellectual effort they were putting into that activity that they had just engaged with. Perceived instrumentality or usefulness or relevance. How I performed on the activity will impact my future. So there's a number of different items for each of these scales. Self-efficacy or understanding or confidence, like how successful you felt on that activity. And social engagement. So this was the scale that correlated with status raising. And this one I'm going to get into more and show you all the items. So social engagement, this is one item. I had the opportunity to ask questions during that activity. So I'll share with you all of the items from the social engagement scale. I had the opportunity to ask questions during that activity. I built on other people's ideas during that activity. I felt like my contribution was respected and I felt supported by my teacher. So you could see it's about involvement and feeling valued socially during that lesson activity. So again, the research question was investigating the ways of providing academic and social support and how those teaching practices may align with students' reports of productive engagement in the moment. So we had a series of conjectures of potentially engaging teaching practices that we investigated. And then we looked at how that correlated with different kinds of engagement that students reported. So one significant finding that we are highlighting today is students' reports of social engagement correlated with teachers' enactments of these status raising practices. Also, motivational discourse, what I mentioned earlier, this is when a teacher focuses more on learning and sense making over performing and achievement. It's when a teacher is kind of lighthearted with the students, uses humor, enthusiasm, and also promotes collaboration. And I have that rubric for you later if you want to ask about that during questions if you'd like. So these two teaching practices correlated with students' reports of social engagement. So in preparing for this talk, the teachers didn't know what we were looking at when we were observing them. And so I shared with Jen transcripts from her classroom, and she reflected on that with me. And so she would share with us tonight a little bit about her thinking there.
Yeah, so I was very surprised at these rubric scores. I was surprised at how consistently high they were in both the status raising language and the motivational discourse focus areas. My classroom is typically very student focused most of the time, and mathematical conversations among small groups are the norm. This data indicates to me that students are most likely engaging in those mathematical conversations because they're receiving consistent social supports, such as status raising language that makes them feel valued. They're receiving motivational discourse cues from me that's encouraging them to continue grappling with the given problem. So this was a very nice surprise. Next slide, please. So this data was very impactful to me as well, because this really represents a strong collaborative space where kids feel that they can safely express their mathematical ideas, where they feel respected and supported not only by me, but by their peers. And I feel that, that feeling of safety and support lends itself to students freely sharing their ideas and being willing to engage in the math.
And so this is what the students were saying in that class period that we looked at in that transcript. This is what they reported on that social engagement scale. And one thing that Jen and I were talking about was it's really interesting because she didn't actually say something about every single student's strengths in the room, but students felt supported even if they themselves weren't the ones whose mathematical strengths were being highlighted. I mean, the highest score on these was 5. So these data were interesting to look at with you, Jen. Okay, and so the headline again is that high school students in these 72 lessons tended to report higher degrees of participation in math learning activities for their social engagement during lessons when teachers were making these efforts to provide these social supports like status raising. And then I can share more about motivational discourse if people are interested. So we thought that one important aspect of this study is that investigating relationships between researchers' observations of teaching and students' self-reports of engagement in the moment could be potentially revealing. A big motivation in my work is I want students to teach us of what matters to them. And so surveying the students immediately after that activity, the students can teach us ways that teaching is engaging for them. So looking at these relationships between the students' self-reports and the teaching we observed, it was revealing for us to uncover potentially engaging instructional practices in secondary math classrooms. So we had students being the informants with the survey, teaching us, and then the teachers teaching us by the teachers selecting the activities that were potentially engaging and telling us why they thought it might be engaging. And then I invited Jen to share a bit about what she learned.
So I really enjoyed working with Mandy and her team. They were all really fantastic. At the end of the study, Mandy shared all of the data with me, and I was really surprised to see how high the students rated their level of engagement and how positively they viewed the classroom environment overall. I was honestly very surprised to see those rubric scores, how often I used status raising language and motivational discourse cues. This relationship between, my interactions with my students and their feelings and their level of engagement makes perfect sense after talking to Mandy, because we all respond positively when we're getting that feedback, that positive feedback from people. So I guess, giving students all that those encouraging words really does impact their engagement. I'm a type A personality, and I'm always looking for ways to improve my teaching practices. And after really digging into the data Mandy gave me at the end, I saw that there was one class's data points that were notably lower than two of my other classes. And this was a class that was slightly more behaviorally challenging. It was a class that I had right before lunch. I had already taught this whole lesson twice. And, we were all hungry, we were all tired. And quite honestly, I didn't have the same connection with this group of students that I did with my other two groups. And it was reflected in that data right there on the paper. It was undeniable. And, after some reflection, it really hit home to me about how my interactions with my students, my communications with them, the way I, speak with them, my emotions, my patience levels, all of those things play into their feeling about my class and how willing they are to be engaged in the mathematics. So, I appreciate, it was hard to look at that data, but I did learn from it, and that's what all of this was about. So I was very grateful for that opportunity.
And it shows us how in the moment these interactions can be and how situated they can be. And I always appreciate Jen's openness and reflectiveness and how she's always trying to challenge herself to grow.
Thanks.
And this project has a number of different research questions and papers that we're working on. We have a paper under review about teachers' orientations toward math engagement. As another part of the study, we interviewed the teachers about what they thought engagement was, and we watched video clips with them about their teaching, and they talked with us about how they saw engagement or not during the lesson. And so we have a paper under review about different ways that secondary teachers think about engagement. We also have interviews where the students looked at the same video as the teachers. And so we have a paper about how students and teachers notice or interpret opportunities for math engagement, ways in which they notice similar kinds of engagement, ways in which they notice different engagement. And so that's been revealing for us. And then we are also charting how students' motivation engagement change over time in the first 2 years of high school. So the SMILES project, the L stands for longitudinal. So we followed the students, a number of the students for up to 2 years. So we have multiple administrations of this experience sampling method. We have surveys that are beginning and end of course. And so we have a number of different data points that we can look at to see students' motivation engagement over time. So this is a larger study, and looking at the teaching practices is one piece of it, but understanding engagement from teachers' perspectives has been important. Focus groups with students looking at the videos from the class has been illuminating as well to accompany the survey look at the students' experience. So we are ready to talk with you about questions, and also in attendance are other folks that work on this research project who can jump in and support with questions. But if you would like to talk to us more, you can see our email addresses. This is my professional website with references to papers. If you want to follow each other on Twitter, that's my handle, Mandy Math Ed. And thank you so much for spending time hearing about this project tonight. Thank you.
Great, thank you so much. Yeah, so we have some time for questions. We have about 14 minutes left in this presentation time. So I'm going to say let's take about a minute. Let's think of the questions. Let's spend some time just, thinking about what we want to ask. And if you want to drop that in the chat, that's a great way to do that. Or we can start opening up for people to chime in the Zoom room as well. So. Yeah, think of some questions. Let's have a discussion.
You can also unmute if you want to just ask that way too, right?
Yeah. Can I ask a question?
Sure, Kathleen. Hi.
Sure. My question is, Maura, did you think that it changed students' views on learning mathematics, not just themselves, but what's the nature of learning mathematics when they see themselves as more in positioned as problem solvers and not just worried about getting answers? Because sometimes one of the things you said that they felt supported, and so what I deal with sometimes is that when I have students engaging like in groups they feel like they're not supported because I'm not telling them if they're right or I'm not telling them if they're wrong. So they like as though I'm trying to promote this problem solving culture, they feel like I'm not being supportive. I know eventually like they appreciate that they came to it, but I wonder how their thoughts about like what does it mean to be a math student, to actually learn math? How do you think it impacted that?
So how we got at that, the closest thing I would say that we got at that is that we asked them to watch a video with us. So first of all, we asked them, what does it mean to be into math? That's how we started the interviews with focus group of kids. What does it mean to be into math? And so just like teachers have different views of that, students have different views of what it means to be into math. And we strategically chose students for a focus group from the survey at the beginning of the semester so we could get a range of different kids. So we are trying to get a range of different views. So we weren't collecting in this interview what the majority of kids think. We're thinking the range of the kids. So students have different views of what it means to be into math. And then they watched the video and they pointed out when they thought engagement was happening. And so there is a way to look at that to think about what they think the student's job is, right? But we didn't necessarily use that lens, but I think it comes indirectly when we think about what they think it means to be into math. So is my job, so for instance, a lot of students say, this isn't too surprising, but I'm into math when I'm really understanding it. Or they'll say, that's the most common one, but they'll also say, I'm into math when I could be really interested in it, or I'm into math when I'm working with somebody I want to work with. Like they say all kinds of different things. But I think that wasn't necessarily the focus of our analysis. So it's hard for me to say with confidence.
I'm just hoping like it's an incidental byproduct. That would be really great as a person who is probably teaching Gen students right now. So that's nice.
Yeah. So one conjecture you might have, it sounds like, is what students think their role is as a learner is going to be a big part of how they might engage with the learning environment that you're creating. It's a good one. So we have some questions in the chat. Morgan, do you want to unmute and ask it out loud?
Sure, happy to. So I just noticed that you've been able to cultivate what seems like really good research relationships in classrooms with teachers. And I know that that's something that a lot of people really struggle to get started. And I wonder if you could talk a little bit about the process of building those relationships or negotiating that access, maybe some strategies and tips for folks who are interested.
How did we get good relationships with teachers? So Jim Middleton at Arizona State and I have lived in our states for a while, so I wasn't an early career person. But when I did meet teachers earlier in my career, I worked with folks who already had good relationships with teachers. So in Delaware, we have an organization called the Delaware Math Coalition that provides a lot of professional development throughout the state. And I was able to meet many amazing teachers and math coaches that way. And then they introduced you to other folks and so on. In the case of this study, at each of the 3 school sites that we worked with eventually, math coaches and curriculum coordinators introduced us to one teacher. And in that pilot year of the study, Jen was the teacher at her school. And Jen, I don't know if you remember this, but we held a meeting at your school and you kind of vouched for me.
I did, because you were looking to follow the students that I had the following year. And so that was going to be a whole other set of teachers in our building. And I just, I encouraged them to do it because you and your team were just spectacular. And I just felt very supported and encouraged that, I was doing good things in the classroom. And so why not have everybody be able to benefit from that?
So I would say that during the pilot year, we collaborated with the teachers and we modified the design of the study with the pilot teachers. We were overly ambitious. We were going to observe and survey way more than was realistic. So talking with Jen, she would be like, yeah, maybe we don't want to do this many. The teachers helped us. modify the design during the pilot year. So I think that is a key in the relationships, is when you work with the teachers rather than zoom in and like take data and leave. The teachers that we worked with, I wanted them to be collaborators. And so Jen and the other teachers that we worked with the pilot year, based on their feedback, we changed the study. And then they trusted their colleagues. Oh, this is what it's like to be in this study. It sounds like it's a lot of work, but when it's spread out across the semester, it's not so bad. So fortunately, the relationships we developed the pilot year really helped us facilitate working with other teachers. But relationships are everything. I always constantly thank the teachers that allow us to learn with them, because I couldn't learn anything if the teachers weren't open with us. So I'm glad you asked that, Morgan, because I think that's huge, these relationships and access. And Jim Middleton is here from Arizona State. I don't know if you have anything to add, Jim.
I would say ditto is probably the best thing to add. Relationships build reform. Relationships build a research program. And however you start, and and I don't know if there's any best way to start. I had a colleague take me out to schools, and it turns out the first school I went to was a school that I stayed with for like 12 years. He said, "This is a great school. It has a lot of young teachers in it, and and also I didn't go out to do workshops in professional development. I went out to have a conversation, and it was very much exactly the way Mandy describes. I want to learn with you, and there's no teacher in this school that I can't learn from, and that doesn't do a better job than me at probably most things in their classroom. And to go in and really with your eyes open and look at things and ask teachers why and how this worked. And they're very open and have been very open and honest with me. And then cultivating those relationships over the years. So I work with some of the same people. I'm long in the tooth for 20, how many years have I been at ASU? 26 years. I've still got many of the same teachers that they call me up. Hey, Jim, we're going to do something. And I say yes before I even know what it is, because that relationship cultivates that kind of trust. And it's going to be good, and you're going to get publications out of it. And you don't care about that so much. You care about working with your friends.
Thanks. Layla, I see that you have the next question. Would you like to unmute and ask?
Okay. Oops. All right.
Hi.
Okay, Mandy. So what I was interested in incorporating the practice standards, which I think were meant to be a discourse guidance in mathematics class. So you see teachers incorporating, or did you consider the practice standards, or how is it is it kind of sitting there on the side, more or less?
I would say some of our academic support rubrics align with practice standards such as perseverance, sense making, and problem solving, because we had academic support rubrics around supporting students with sense making and explaining their reasoning and that sort of thing. We developed our conjectures for engaging instruction kind of independently of the practice standards, but you could see relationships there. There are some, though, that we did not investigate relationships with the practice standards. And so that's an interesting question. If teachers are using the practice standards, what do you see for engagement? But I would say we emphasized more the persevering and problem solving and reasoning standard over the other practice standards. Okay. What do you think about the practice standards and engagement?
Well, I think that if a teacher can really focus on it authentically with students, and students can sort of integrate it within their thinking, that besides the content of math, there's a certain behavior that we're going to focus on along with learning. I think they're going in the right direction.
Yeah.
So I think it's more of a grounding, type of generic. And then I feel that Jennifer evolved into, more specific towards her students that she had in terms of that kind of support. So.
Thank you. Looks like our next question is from Charles Hohensi.
Yeah, thanks, Mandy and Jen. I was just curious if you noticed any trends, and maybe Jen can answer this too, in the types of activities that teachers thought would be engaging. Were they, when they had manipulatives, or was it like all sorts of activities? Was it like the beginning of class or the end of class? Any trends there?
Yeah, so there were a lot of different types of trends. One would be around group work activities were engaging for students according to teachers. So you're asking about their conjectures, like what activities they thought would be engaging. Some would be, games like scavenger hunts and things. Some would be, this activity uses a lot of technology. And you saw with Jen's reflection about her activity, some of the activities were about, I'm going to challenge students' conceptions. And so the teachers could give conjectures in whatever dimension they wanted. And so sometimes it was around the group work experience, sometimes. So we've actually analyzed that, and it could be a way that we could use as a moderator for the different types of activities and the relationships between instruction and student experience. I don't know, Kathy is one of the research assistants on this project who helped with coding those activities. Kathy, do you agree with how I characterize those?
Yeah, I was just looking for a spreadsheet here to remember how we did that. Yeah, I mean, sometimes the teachers were just like, this is what I'm doing today. And other times they're like, yes, come on this day because we're doing this activity. So it varied. Sometimes because we were working on the schedules that worked for them. So
right. So sometimes it was just a typical activity.
Right.
It wasn't like a special lesson.
Right.
Right.
Yeah.
Peter, we're at 7, and I did get to answer everyone's questions, but I'm noticing we're at 7 or 4 o'clock for California.
True. I think there's only one question left that we haven't gotten to yet. Is that correct?
Nicholas?
Yeah. So if you want to look at that question and respond to it, I feel like we can go a couple minutes over it as you do it. So.
Oh, I don't have that data right here with me, the average social engagement score for all the teachers. But Jen, you have a question here. What's that?
1.5 out of 3 plus or minus 0.6.
What are you saying?
The average social engagement score.
Oh, so Jen's was high.
Oh yeah.
So
I mean, right in the middle, right? Which basically right in the middle of the range.
So Jen, why do you think you use motivational discourse and student positioning language at a higher level? Did you know about this strategy? Did you learn it in PD somewhere? They want to know, how did you learn how to do this?
No, and in fact, I was very shocked to see that, giving students praise and calling them out for their good ideas and thinking mathematically had a term. I didn't realize that, status raising was a thing or motivational discourse was a thing. And, it's just, I guess, my personality and wanting to encourage kids to step outside their comfort zone. I know we always talk about kids who have that assigned knowledge about their own math identity. And my goal is always to have kids who come in with a negative math identity to leave my classroom with a positive math identity. And so I just incorporate, those different strategies of lifting them up to trying to change their own perspective about themselves as mathematicians.
So we were not working with teachers who we had already worked with in a professional development capacity. We wanted to see what was happening. So teachers don't always have the language to know in the same way that the researchers have the language. Teachers have their own language, which is also good. So I was characterizing it from researchers' language, but Jen already had the mindset for this kind of work.
Great. And there was one last question for Jen that came in that I want to honor here, and then we're going to cut it off after that. So this is from Ruth, who asks or says, I would like to know if Jen considered it or classified how best her students learned before coming up with an activity.
That's a great question. Well, in this particular lesson, we had to introduce the topic of exponents. I know that I teach this course alongside several other teachers, and we typically teach very similar lessons. On this particular lesson, I did deviate from, what had been planned by the rest of the group. I thought it would be fun to have high schoolers, sit quietly while the teacher read them a story aloud to introduce a topic. And so I don't know, I just thought it would be kind of fun. We always think that our high schoolers, don't enjoy, reminiscing about their years as small children in kindergarten, sitting in a circle, listening to a story or whatever. So I just thought it would be a nice way to introduce the lesson in a, just in a fun way. And so there.
Great, thank you so much. Mandy and Jen, thank you so much for being here and sharing your work. This was wonderful to hear about the amazing things that you're doing, and we appreciate your time and appreciate your generosity in sharing what you've been doing. Usually at this point in the presentation, I would tell you about all the wonderful speakers that are coming up next, but this was the last one. We're done. So this is the end of the 2021 lecture series. If this is your first time here, thank you so much for being here. If you've come to multiple events, thank you so much for being here through across the past academic year. My dogs are also thanking you for your involvement in this process as well. So one other thing to say is that on YouTube, all of these lectures are recorded and you can see them and you can find them as well. So do check that out if you want to see what other folks have said, or if you want to come back to this lecture and go back to this wonderful information. And so with that, I'll say thank you to our speakers. Thank you for being here, and we will see you soon. So good night, everyone.
Thank you for the opportunity. This was great.